Dhanasegar is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. So, we have the subject compiler design for this episode. And let us recall the topic which you have seen as far as the previous episode is concerned. We are studying actually the bottom up parsers. So, we have already seen one bottom up parser, one is the shift reduce parser, which constructs the parse tree in a bottom up approach from the leaf node to the root node by shift action or reduce action. And finally, we will accept this string provided we have reached the start symbol of the grammar as the label for the parse tree root, and there is no more symbol on the buffer. And the next bottom up parser is the one called operator precedence parsing. As far as operator precedence parsing is concerned, we wanted to have an exclusive type of grammar which is called the operator precedence grammar. And say in the case of operator grammar, we should know that there should not be two consecutive variables anywhere on the right hand side of the grammar. So, such a grammar is called operator grammar, and if the relations are going to be disjoint, then we will be calling it as the operator precedence grammar. So, we shall see that is how the operator grammar is being used for constructing the operator precedence parser, which will be used for parsing the string with the help of precedence information. So, let us see that what is the meaning of operator grammar first of all. So, the grammar with no production having two consecutive non-terminals on the right hand side is called an operator grammar, and the precedence, as far as precedence grammar is concerned, so it is going to be a grammar with no epsilon information, that is there should not be any epsilon production on the given grammar. Then the condition is the precedence relation, that is less than, equal and even greater than, are going to be disjoint. So, that is what we call it as an operator precedence grammar, and the three operator precedence relations are one is less than, and another one is equal, and the third one is going to be greater than. The less than says that if it is going to be A is precedentially related with B using less than, A is A is giving precedence to B. That means that is B will be taking more priority than the A. That is the meaning of less than. And if you find equal, which means that, or which is conveying the information that A and B are precedentially equal, and we have a greater than, which shows that A is precedentially greater than B, which means A is taking the precedence from B. That is what we call it as A greater than, precedentially greater than B. So, that is what the three kinds of relations as far as the operator precedence grammar is concerned. So, now there are two methods, that is given a grammar which is known to be an operator precedence grammar. So, we should know that is how do you identify the precedence information, that is the precedence relation among the various operators available in the grammar. There are two methods available for identifying the precedence information from the grammar in between every pair of terminals. The first method is the one which will be used, which is obtained, or we will be constructing the precedence information from the actual precedence of the various operators available in the grammar, provided we all know already in that is advanced. See, for example, if you are having the conventional binary operators like plus and multiplication, we know that plus is taking lower precedence than the multiplication, and if we find that plus and minus are available, they are equally, that is their priorities are going to be equal, but still there is a condition that the order of evaluation should be from left to right, which means when you are having plus and minus, something like an expression A plus B minus C, we must compute a plus b first and then it will be subtracted by the c, but we should not go for computing b minus c, then it will be added with a. So, that is a violation of the associativity information. So, there also we need to have some information about the precedence. So, if you know the grammar in advance and if you know the relationship among the various operators available in the grammar in advance, then we can straight away generate the precedence information. So, that is what we call it as precedence information from the associativity of the various operators. And the second one is we will go for constructing the parse tree. So, when you go for the parse tree, so that is from the parse tree we can very easily identify whether that is an operator takes more priority or less priority than the that is other operator. So, whenever you find an operator is available on the lower level, it takes more priority because it should be computed first, and if it is there on the lower levels, that is very close to the root or even the that is in the b, that is even before the prior levels, then we can say that they are going to take the that is your lowest priority. Lowest priority means they will be computed last. So, low priority operators will be computed last and high priority operators will be computed first. So, that can be very easily obtained provided we construct a parse tree for the given sentence. So, that is what we have two methods. One is from the known precedence and associative information we construct the precedence relation, and the other one is just construct the parsing table, parse tree, and from the parse tree based on the levels of the availability of the various operators, we can identify the various precedence relations. So, let us see the first method, that is how the precedence information is going to be obtained from the associativity and precedence of operators. So, in general we shall take two operators, one is going to be theta 1 and another one is going to be the theta 2, and the condition what is being stated is if an operator theta 1 has higher precedence than the operator theta 2, then how do we set the relationship? So, we should say that theta 1 is greater than or having higher precedence than theta 2. So, theta 1 should be greater than theta 2, and it implies that theta 2 is having lower precedence than theta 1. So, we should set the alternate also. So, theta 2 is precedentially less than theta 1. So, two things are there, one is theta 1 is greater than theta 2, that is theta 1 takes precedence from theta 2, and the next one is we should know theta 2 yields precedence to theta 1, that is theta 2 is going to be smaller than theta 1. So, the example here we have the first one is multiplication is greater than plus, and in reverse plus is less than multiplication. So, this is what how we are getting, that is in that case we do not consider the associated information, and suppose if you want to take the associativity also in the case the like plus and plus. So, we should know that the first plus is to be evaluated first. So, first plus is greater than the second plus, that is what the information we are collecting from the precedence and associativity. And the next case is, so if you are having two operators once again, the first operator is theta 1 and the second operator is theta 2, and the condition is they are having same precedence, that is both theta 1 and theta 2 have the same precedence. So, in that case we are having two types of two conditions. One is how do we set the priority if the operators are left associative, and the second one is how do we set the priority if the operators are right associative. Because if you know that the operators are having difference in priorities, then automatically they will take the higher priority or lower priority depending upon their that is precedence information. But when you know that they are having that is two different operators, but they are having same priority or same precedence, now the relationship is set by knowing what is going to be the associative information, whether it is left to right associativity or it is going to be right to left associative. So, if it is going to be left to right, then in that case we should know that theta 1 is precedentially greater than theta 2. It is because of if theta 1 is on the stack and theta 2 is on the buffer, because of they are equal in priority and the associativity is from left to right, we should give importance for theta 1. So, theta 1 gets reduced before shifting theta 2. And one more thing is, Here we are saying the contradicting the relationship, that theta 2 is greater than theta 1. What it means is, so this theta 2 is now in the stack and this theta 1 is on the buffer, that is, this is already on the stack and this is now the new operator coming into the picture. So, when you find that these two are having equal priority, whatever is already available on the top of the stack, it is because of the left associativity, whatever is then already on the top of the stack is going to have more priority. So, that is the reason why we said theta 2 is greater than theta 1. So, here theta 1 is on the stack, so it gets more priority. Here theta 2 is on stack, so it gets more priority. And when you go for right associativity, here theta 1 is on the stack, so it takes less priority. Here theta 2 is on the stack, so that gets less priority. The precedents are going to be same, but as far as the priority information are concerned, theta 1 is going to be precedentially less than theta 2 and theta 2 is going to be precedentially less than theta 1 because of right associativity. So, the examples here, we know that plus, multiplication, star, slash, so all these are taking the associativity from left to right. So, here it is plus is greater than minus, since plus is, suppose if you have an expression called a plus b minus c, the first a plus b must be computed. So, for that we have greater than relation, and minus greater than plus, it means when you are having a minus b plus c, first you compute a minus b, then you go for added with c. So, that is what we are having minus greater than plus, then plus greater than plus. If it is going to be a plus b plus c, then first we have to compute a plus b, then we have to compute the result of a plus b with c, and then we are having minus greater than minus. But what happens with the associativity? So, there is a right to left associativity. So, we know that the exponentiation is going to be a right to left associative operator. So, when you have one exponentiation operation on top of the stack with another exponentiation operator available on the buffer, that is a newly coming that is operator, then the newly coming operator will take more priority than the one which is already existing on the stack. So, that is what we said, exponentiation is precedentially less than the exponentiation. The exponentiation one which is precedentially less is going to be on top of the stack, and the one which is having more priority is going to be on the buffer, which gets shifted onto the stack because of the relationship less than in between exponentiation and exponentiation. And the last one is going to be we are having that is a theta, there is any operator, and what is the relationship among this that is in this operator with the rest of the tokens. So, the rest of the tokens means it can be an identifier or it can even be there is opening bracket or closing bracket, whatever it is. So, theta is less than there is always precedentially less than any identifier. It is because of when you have an identifier as the next token with an operator on the top of the stack, it is going to be a binary operator, means the operator cannot be reduced without knowing its operands. So, what should be done here is, when you find an operator on the top of the stack, immediately you push the corresponding operand also onto the stack. So, if you want to push the corresponding operand onto the stack, so we must set the operator which is there on top of the stack is precedentially less than the new operand. So, theta less than id. The next one is id is precedentially greater than theta. So, here it is going to be one identifier and the next one is going to be an operator. So, when you find an identifier, we should know that this identifier must be converted in an expression, so that we will be able to do this operation with another binary operator. So, the only possible operation here is going to be greater than, which will go for or which will be initiating a reduce action for this, that is id. Then theta is greater than dollar, saying that this must be computed, because already we have reached the end of this string, and dollar is less than theta, and it says that we do not have anything on the stack, but we are having an operator. So, we must shift it onto the stack, saying that it must be only the valid movement, but we can't go for reduce option. Then similarly theta less than there is opening bracket. So, we have an operator and we have opening bracket. So, any expression which is inside the opening bracket and closing bracket will be taking more priority than any other operator. So, that is what we said, theta is precedentially less than opening bracket, and opening bracket is precedentially less than theta, because when you find opening bracket on top of the stack, it must be shifted towards the, or the next operator should be shifted onto the stack rather than going for initiating for a reduce option. So, then we have opening bracket greater than theta and theta greater than, that is closing bracket, and this all to be applied for every operator. So, irrespective of whatever be the operator we are having, so we must set all these relations, especially with a grammar which is meant for arithmetic computations. So, closing bracket is greater than theta means you compute anything or everything available inside this closing bracket on expression, so that the next operator can be that is shifted whenever it is we have nothing else for the execution on the or evaluation on the stack. And similarly, theta is going to be greater than closing bracket. That is, when you find a closing bracket, the expression preceding that, if there is no opening bracket there, the expression preceding that until we reach the opening bracket, that is the meaning there. There should be a reduce operation, and where the theta mean already I said that is going to be any operator. So, that is about the that is your identification of, that is precedence information as far as your the expression grammar is concerned. So, we should know the precedence information, and then we can set the appropriate that is precedence for every pair of operators. So, there is one more method I said, it is how we are constructing the precedence information from the parse tree, but we shall see that after a short break. Welcome back. We have seen the construction of the precedence relation from the grammar, but first method is with the help of an operator precedence information, and the second one is from the parse tree. So, now we shall see that is how we are constructing the precedence information or the precedence relations among the every pair of operators with the help of a parse tree. So, the three relations already I said, that is, one is the less than, another one is equal, and the last one is going to be greater than. So, there are three steps available, that is how do you set the less than relation, and how do you set the equal relation, and how do we set the greater than relation. Let us see that is one by one. So, the first one is the equal relation. So, we have there is two there is tokens or operators, we can say that one is A, another one is B, and if you are having a right hand side of the production, so here we have alpha, A, beta, B and gamma. So, what we mean by here is that is A and B are any two terminals, or it can even be called as operators. Alpha and beta may be any sequential forms. So, this alpha and beta may be any sequential forms, but we have a condition that beta. So, that is what is in between A and B. In between A and B we have a beta. So, this beta is either an epsilon or it is going to be a single non-terminal. So, if it becomes an epsilon, what happens to this alpha A beta B gamma is alpha A B gamma, that is when beta becomes epsilon. So, what happens, A and B are becoming two consecutive terminals, which is allowed by the definition of an operator precedence grammar. So, if you find that two consecutive terminals are there, they are precedentially equal. That is what we mean by A and B here. And one more case is this beta can be even a single non-terminal also. So, if beta is single non-terminal, then we will be having the situation like A followed by a B followed by another B. So, that B it is going to be a variable. So, in that case we have a situation like two terminals separated by a variable. In that case also we must set A is precedentially equal to B. For an example, we have a production called S derives I, C, T, S, E, S. So, the first case is we can take in between, that is I and T. there is a variable in between I and t. So, that is nothing but your beta as far as the general procedure is concerned. So, you can set that I and t are precedentially equal, and here t and e are also precedentially equal, but we do not have two consecutive terminals. So, we can ignore that concept, that is case, but we have terminals separated by variables. So, two terminals I and t are separated by c. So, I and t are equal, t and e are separated by s. So, t and e also equal. This is how we are identifying the equal relation. The next is, how do we identify the less than relation? That is how we will claim that the two operators a and b are related by the less than symbol or less than precedentially less than operation. First, it is going to be for some non-terminal a, and there is a right hand side of the form alpha a, capital A and beta. This alpha can be any sequential form. A is supposed to be a single terminal, that is an operator here we mean, and this capital A is going to be a single variable. Then once again followed by beta, you can have anything as far as beta is concerned. So, what should be done here? That is, we have capital A. As far as capital A is concerned, definitely it will be having a production or it will be having a derivation. So, what is the derivation? So, A derives in one or more number of steps some gamma followed by b followed by delta. That means, you have to find out all possible derivations of this A, where your gamma is epsilon or a single non-terminal. So, what it means is, when you generate the sequential forms of this A, you find out the first terminal. Already gamma is there, but gamma is epsilon, it may not exist, or it may, if it exists means it should be a single variable. So, how will you handle the situation is, A's derivations are all going to have B as the first terminal. So, in that case, if you go for a construction of the parse tree or if you go for parsing, what happens is, the derivation, that is gamma b delta, will get reduced to A even before alpha A capital A b gets reduced to its parent. So, what happens? Your A is precedentially less than B, because B is having more priority than this A. So, in this case, here we find the that is production called S derives ICTS and C derives B. So, we will be having a derivation for C to B, but in one or more number of steps. Now, how we are setting the relation? To set the relation here, we will be having this I, and it is to be related with all the first terminals from C. The first terminal from C, or here it is going to be B. So, I is precedentially less than B, and that is going to be true for even that is all dollar is less than B, provided this B is the first symbol as far as the start symbol derivation is concerned. So, it is going to have a if you are having a dollar on the stack with the first symbols of S on the buffer, it signifies or it is going to introduce a shift action. So, the condition here is where your gamma is either epsilon or it is going to be a single non-terminal. So, we have seen two number of relations, one is less than, another one is equal, and the third one is going to be your greater than. So, that is going to be similar to a less than, but with modifications on your residential forms. Here you see that alpha, A, B and beta. So, alpha is any sequential form, A is a variable and B is a terminal, it can even be an operator also, and beta. And now, the derivation is your A derives in some number of steps gamma A delta, and your delta is going to be either an epsilon or a single non-terminal, it is not gamma, which means, so your A is going to be on the lower level than this B. If you look at the parse tree equivalent for this alpha, A, B, beta are going to be in a level which is smaller than the level of the gamma A and delta. So, gamma A delta gets reduced to A even before alpha A B beta gets reduced to in the appropriate left hand side. So, that is what we said, A has more priority than this B here. So, once again in this particular production, where S derives I C T S capital S and C derives B. So, if you are interested in setting the relation in between B and T, so your B has more priority than this T. So, that is how we are setting the greater than relation. And also when you find any operator A, if it is mapped with dollar on the current input symbol position, we must always set that the relationship is going to be greater than, because we cannot do any shift, that is any further shift is not possible from the buffer, as we do not find anything else in the buffer. So, the only possible action there is reduce or carry out as many as reductions possible for the handles available on top of the stack. So, reduction is the only solution. That is what here we mean, that is we have A greater than dollar if S is that is generating gamma A and delta in some number of steps, where your delta is either a single non terminal or it is going to be an that is epsilon. So, this is how the three relationships are going to be generated in both methods, like one is the precedence information method and another one is going to be the parse tree method. So, now the question is, how will you use the precedence information available in your precedence operator precedence grammar? I said three relations are there, one is less than, another one is equal and another one is going to be greater than. So, we can make use of these relations by going for mapping it with the shift action or with the reduce action. So, if you go for a shift action, we have to find out that we are still to find out the handle. If it is going to be reduce action, it means we have already identified the handle, and if you are with equal operation or equal relation which says that some portion of the handle is available on the stack and some portion of the handle is available on the buffer. So, that is what we mean by these three operators. Less than denotes the left end of the handle, greater than denotes the right end of the handle, and equal denotes the middle position of the handle. So, accordingly we will be setting the that is priorities and associated information, and we will form the precedence table. So, to summarize, so we have seen the operator grammar, what is the meaning of that, and then we have seen the operator precedence grammar also. So, the condition is the relationship among the operators must be disjoint. So, that is about the operator grammar, and there are three relations available, less than, greater than and equal, and these relations are identified by either using the precedence information or by using the parse tree that is method. And as far as the question component is concerned, so the meaning of the precedence relations and how the precedence relations are going to be used, and especially with parse tree, and how the precedence informations are going to be that is obtained. We have already seen that three relations are there, and by expanding the various production rules available in the given grammar with the help of there is derivations. So, we can find out what is going to be on the lower level and what is going to be on the higher level, that is what is on the that is close to the root and what is far from the root, and the things which are on the that is lower levels will be always having lesser priority than the things which are available on the that is higher levels, because the higher level things are getting reduced much faster. So, we give more priority for the operators which are there on the higher levels. So, that is how we are identifying and making use of the results. So, with this I complete this episode. Thank you all.